Hello, and welcome to the headquarters of the Toyota Research Institute in the heart of Silicon Valley in Los Altos, California. Originally, we wanted to host our first ever open house to showcase our robotics research and introduce you to our new mock home research lab. However, due to COVID-19, we had to get creative. So we're trying an experiment to give you an immersive experience, which we hope will be better than standard video teleconferencing. I'm Gil Pratt, the CEO of TRI and Chief Scientist for Toyota Motor Corporation. I am speaking to you now from a TTR-1 robot, which is a research prototype that TRI developed to explore how we might give people a better virtual mobility experience. It has a 360-degree camera, just like the one that you're currently viewing through, and a life-size display in the other direction. Like everything we do at TRI, TTR-1 is part of our research to see if we can create a new capability. In this case, a capability to help a remote person to be more physically present at another location. So I hope that you will give us feedback on what you think of this new way of experiencing our facilities and robotics work. We're so excited to have you here, so let's go inside. This is our all-hands gathering space. Normally, we would be giving presentations from this stage, and you would all be in the audience together. But today, we're going to try something a little different. I hope that you enjoy it, and with that, let's get on with the show. TRI, the Toyota Research Institute, was founded in 2016. Our job is to be explorers and discover and create the new capabilities Toyota will need in the future. Toyota approaches the future from a human-centered perspective, with the goal of bringing deep happiness and fulfillment to all people. On a fundamental level, this pursuit is based on a powerful idea that each person's life should have meaning and purpose. In Japan, this is called ikigai. Studies of ikigai teach us that we feel most fulfilled when our lives incorporate work that we love and that helps society. To enable more people to achieve their ikigai, we are pursuing new forms of automation with a human touch, to develop capabilities that amplify rather than replace human ability. This is Toyota's historic philosophy of jidoka, an idea that takes the concept of artificial intelligence, or AI, and turns it around to become what is known as intelligence amplification, or IA. In other words, the human and the machine work together to do something better than either one could do by themselves. We are currently pursuing this vision in 4 research areas: robotics, automated driving, accelerated materials design and discovery, and machine-assisted cognition. Today, we are going to talk about our robotics research, particularly robotics that provides human assistance in the home. But let me first briefly tell you about our other research areas to give you a full picture of TRI. In automated driving, we are developing 2 approaches to move the industry forward. The first is Toyota's Guardian technology, which provides a safer and more engaging driving experience. The second is chauffeur technology, which is Toyota's fully automated self-driving system. In accelerated materials design and discovery, we are developing tools to design new materials for zero-emissions mobility. Finally, in our newest research area, machine-assisted cognition, we are focused on better understanding and predicting human behavior, particularly in the context of decision-making. TRI has 3 offices strategically located outside major research universities: Stanford, the University of Michigan, and the Massachusetts Institute of Technology. We fund and work closely with these 3 universities as well as many others. In addition to our research activities, TRI has also helped establish 2 new companies, Toyota AI Ventures and TRI Advanced Development, or as it will soon be known, the Woven Group. Toyota AI Ventures is our corporate venture capital subsidiary that strategically invests in early-stage startups. The Woven Group focuses on translating research from TRI and other parts of Toyota into new products and businesses that will be tested in Toyota's Woven City. The Woven City is a prototype city of the future on a 175-acre site being planned at the base of Mount Fuji in Japan. This is where TRI's technology, along with others, will first be tested and improved by the Woven Group. Now, to truly understand what it means to work at TRI, I would like to introduce you to our Executive Vice President, Chief Financial Diversity and Inclusion Officer, Kelly Kay. Kelly?
Hello, everyone. I'm very happy to welcome you to TRI and give you a glimpse of what we've been doing in the robotics space. But first, I want to tell you a little bit about why I came to TRI and how it connects to our vision for robotics. About 3 years ago, my stepmother had just had 2 strokes. Soon after, she fell at home and my father, who is himself disabled, fell trying to get her up. I received an urgent call from my father while they were in the emergency room and felt utterly helpless being so far away. This incident made me question, how long will they be able to take care of themselves? How can I care for them living so far away? And even if I was there, would they accept my help? My father is a proud man. He would never take assistance or allow a caregiver in the home. I'm sure many people have dads just like mine, dignified and independent. The idea of taking away his workshop or his kitchen to go to a nursing home, or having someone come into the home to help, they're just not things he would consider, nor could they afford. My heart aches to find a solution to allow them to stay in their home for as long as possible. And while all this was going on, I was approached by a recruiter from TRI. She was telling me about the vision and the mission of TRI and the amazing projects that the team was working on. And I thought, wow, I could go work at a company that's actually trying to change the future and enable people like my father to be able to remain in his home, care for himself, and keep doing the things he loves. I know TRI's results won't come in time for my dad, but maybe they could be ready for generations right around the corner. Maybe they could even be ready for you and me. TRI's vision and mission center on solving this very problem. How can technologies amplify and ease the human experience, bringing forth a higher quality of life, independence, and happiness? At TRI, we envision a future where Toyota products dramatically improve the quality of life for societies around the world. And our mission is to develop automated driving, robotics, and other human amplification technology for Toyota. Technology capabilities that will help people navigate safely from their kitchen to their living rooms or safely across town. And most importantly, by providing this kind of human amplification technology, we hope to make the quality of life for everyone much better. People come to TRI because of our mission. They stay because of our values. This combination of purpose and culture has helped us to attract the best scientists and engineers from leading universities and all walks of life. People who are passionate about working on important problems where technology is designed to serve society. Our researchers take pride in knowing that their work can help save lives and improve quality of life for families like yours and mine. Our dedication to improving the quality of life existed before COVID. And now since COVID, it's become even more paramount. Our team simply won't turn out the lights at night and refuse to let shelter in place stop their research. They dig deep and get creative. Some of that creativity we're proud to share with you today. But I think it's so important to understand the level of dedication this type of work requires. The perseverance needed to work on the frontiers of science, where failure is a far more common outcome than success. At TRI, we accept this risk because we know if we're not failing, we're not working on the hard problems. 3 years ago, I made a choice to join a team of leading researchers who are committed to bringing forth technologies to make the world better. Today is my distinct pleasure to share our journey with each of you. We think you will enjoy this unique view of our robotics labs, our team, and why we do what we do. Max Bajracharya, our Vice President of Robotics, is going to be your guide on that journey.
Thanks, Kelly. A major reason Toyota is performing research in the field of robotics is to offer new tools to address our aging society. The numbers tell a powerful story. According to the United Nations, over the next 3 decades, the global population over the age of 65 is projected to more than double. That means over 1.5 billion people around the world will be 65 or older by the year 2050. This graying of the population will have profound effects on society, the workforce, and the economy. As society ages, people will need help at home and at work. In the home, caregivers will certainly be a resource, but we think that advanced domestic robotics can also offer an important tool to help families. Our goal is to create options for older adults to stay independent longer and age in place with dignity. At work, amplifying the efforts of human workers with robotics will alleviate repetitive tasks and help perform functions that humans simply can't. We know that to some, this future with robots might sound scary or even off-putting. But to this point, I want to make an important distinction about the Toyota approach to robotics. At Toyota, we're not trying to replace the human touch of a caregiver or replace the meaningful contributions or creativity of a factory worker. Instead, we believe the robotic capabilities are a key element to giving people back their ability to do meaningful work, work that fulfills their sense of purpose and contributes to society. Similarly, it can help the younger generations be more efficient and save time so that they can focus on what matters to them. That includes freeing up caregivers to perform tasks that require a human sensibility and connection. It also allows technology to pick up the tasks that can be automated without being a detriment to the care receiver. We also believe that if we can address the challenges of making useful robots for amplifying people in their homes, these capabilities can be applied in many different robotic applications. For instance, assisting and amplifying people in manufacturing, logistics, the service industry, or agriculture, among many others. But in all of these cases, the challenge is how to amplify people rather than replace them so that they can retain a sense of fulfillment and purpose. Now, to tell you more about how we plan to turn this Ikigai philosophy into reality, I want to introduce Steffi Pepke, a lead on our user experience team.
As Kelly mentioned, the work we do to develop fundamentally new capabilities in robotics is inherently very risky. So many ideas are going to fail before we find ones that can have a major impact on quality of life. But there's a lot we can do to fail fast, thereby maximizing the chance that our work results in real impact and social good. So rather than simply develop capabilities we find interesting or that we ourselves think will push the field forward, we ground our technical efforts in those areas that address real user needs. Uncovering those user needs is the function of TRI's User Experience and Industrial Design Group. We employ the user-centered design process to uncover people's needs, prototype solutions, and iteratively collect feedback until we arrive at a solution we feel confident in. A common adage is that if the inventors of the automobile had asked people riding horses what they wanted, they would have answered that they just wanted a faster horse. It can be difficult to imagine a future that's vastly different from the status quo. So we don't ask people what they want. Instead, we aim to deeply understand and empathize with the challenges faced by older adults and their caregivers so that we can help identify solutions to those problems. Directly asking people what obstacles they encounter will oftentimes only get you half the answer. Some people are so used to the difficulties they face that they aren't always aware of them anymore. And some people accept that aging has certain side effects and they may take a grin and bear it approach. These people might not think to share these pain points if asked directly. So instead, we use the Genchi Genbutsu, or go see for yourself method. We rely heavily on first-hand observational research techniques such as contextual inquiries. Before COVID-19, we went to Japan to visit the homes of older adults and observe them going about their daily lives, making note of friction points and opportunities. We also identified what's working well to see if we can apply those learnings in our own research. We observed a variety of illuminating details about our subjects' daily challenges, joys, and routines. For example, while many people don't enjoy cleaning, for some, cleaning offers not only valuable physical exercise, but also a sense of purpose and accomplishment. We don't want to create a robot that just does all of the cleaning without regard for individual sensibilities. On the other hand, we have observed time and again that as people age, lifting heavy items such as a vacuum or a bucket becomes more challenging. Bending over or stooping and then getting back up from this position grows increasingly difficult and sometimes painful. It gets riskier to use items like ladders and stools, even though high-up areas still require cleaning. Everyone is unique in their needs and preferences, making it important that we support people in the right way and at the right time. We also observe that cooking is a beloved activity for many, though it can get more strenuous as we age. Sharing meals and feeding loved ones can serve as a focal point for social connection. As cooking gets more difficult, not only do some people lose a beloved hobby, but their social contact might decrease as well. So providing such a person with a fully automated cooking robot or pre-cooked meals might be physically beneficial but emotionally detrimental. By observing a variety of people at home in their natural surroundings, we learn how best to support an individual instead of creating a fix-all that's meant to support everyone with just a single approach. Once we understand these subtleties, we can get to work. We look to provide solutions that address these challenges and find ways to amplify, not replace, human ability. We don't want to just give people gadgets. Instead, we seek to enable people to live with a sense of fulfillment by freeing them of the tasks they are no longer interested in or capable of, and instead empowering them to focus on those activities from which they derive true pleasure and purpose. Here's just one example of such a vision. Achieving this vision is at the heart of our robotics research. Now, Max will take you through the capabilities we're developing that will bring more advanced robots into the home.
Thanks, Steffi. In order to be useful within the home, robots need to be able to manipulate their environment. This is something that human beings do incredibly well. While we learn to do it at a very young age, we find that with robots, this task still proves quite difficult. Of course, we've had pick and place and other robots in factories for many years. But a robot doing something that seems similar in a home, such as picking up kids' toys or dishes from the sink, is significantly more challenging. That's because operating and navigating in home environments is still incredibly challenging for robots. Unlike the structured and programmable environment of the factory, the home is unstructured and diverse. Every home is unique, with a different combination of objects in distinct configurations that are constantly changing. That's another reason that TRI Robotics focuses on the home, one of the most complex environments for robots to master. In particular, we're investigating ways of using machine learning to assist in manipulation. For example, we're studying how to enable machines to learn from experience, the way that a child does as they go from being a baby to being a toddler, learning how to manipulate things in the world with the guidance and the protection of their parents. But actually, robots do have some advantages over human beings. While it takes years for children to learn, robots can learn very quickly from each other. Unlike humans, who share information with visual or auditory data at the rate of tens of bits per second, robots can share information at the rates of gigabits per second. So that brings us to a next stage of machine learning, which we think of as fleet learning. Fleet learning means that when one machine learns something, they all learn something. If we design things in the right way, this can create explosive growth of capability as the number of machines gets larger. We believe fleet learning is going to be the key to making robots practical in human environments. But to achieve it, we need to invent new ways for the robots to acquire, represent, and share knowledge for performing tasks. We're going to tell you about two key challenges. The first is how to enable robots to learn with just a few real-world examples from humans. This means that the robots can use a small amount of data that's specific to their environment. And the second is how to use simulation to both train but also validate robot behaviors, as robots are constantly learning. To demonstrate some of our progress in addressing these challenges, we're now going to give you a glimpse inside our robotics research labs. you'll first visit our headquarters in Los Altos and then our Cambridge lab to see the technology we've been talking about. While we're regularly testing robots in real homes, we've also just created a mock home to accelerate development and testing, and we're showing this publicly for the first time today. This is some of that creativity Kelly was referring to earlier. When COVID struck and we were all forced to work from home, the robotics team devised a way to simulate, test, and then build the mock home that we're about to show you remotely, safely from their living rooms with only a very minimal crew working in the lab. So let's head over to the third floor of our headquarters where Jeremy and Dan are in this new mock home research lab. They're going to tell you how we enable robots to quickly learn from a human teacher.
Hi, and welcome to the TRI headquarters mock home, a robotics testing facility. I'm Jeremy Ma, and this is Dan Helmick, and together we lead a team on developing mobile manipulation capabilities that enable robots to assist and amplify people in the home. Right now, our research focus is on cleaning tasks, and as Steffi mentioned earlier, that's actually quite important. If you ask a majority of people what they think about cleaning, they'll tell you they think it's actually quite drudgery. And even those people that have purpose in cleaning will admit that it's really difficult, particularly when you start talking about those really high, hard to reach places. The bottom line, however, is that cleaning is a necessary part of life. And what we're doing here at TRI is to offer people choices on how they get that done. Toyota's vision for the future is to eventually offer a robot that will assist people on important tasks that they are either unable or uninterested in doing themselves. Now, to get us started, we designed and built this mock home that you see around you. Admittedly, yes, the decor here is rather sparse, but that's actually on purpose. We are not so much interested in putting together a pristine, picture-perfect home representation. In fact, it's actually quite the opposite. What we want is a representation of a home that is good enough for us to test our robotic capabilities. And then once validated here, we go out into the real home and test. And as Max mentioned earlier, when you compare the controlled research facility to the real home setting is like the Wild West. Everything is different. Every house has a unique layout. Some houses have family rooms and living rooms. Some houses have pets. You can kind of get a sense of how every house can be so different, and each with its own unique challenges. For us, the reality is, for this robot to be successful, we're going to have to adapt to unique and ever-changing environments. Let's take a closer look at a simple task like wiping. For a traditional robot, this poses a huge programming challenge. Let me explain why. If you think about what it takes to wipe a surface, there's a lot of difficulty involved in measuring the exact pressure to wipe that surface efficiently. And now imagine all of the surfaces in your home. Maybe some surfaces are made of wood, some surfaces are ceramic, and maybe some surfaces are really fragile like this TV screen. The number of parameters needed to be able to wipe all those surfaces efficiently is huge. It doesn't scale well. And so for us at TRI, we've taken a slightly different approach. We enable our robot to be taught from just a limited set of examples. And then from those examples, it can do a very specific task. Admittedly, we realize that's a limitation, but it changes the problem from being one of needing to fine-tune by hand a large number of parameters to instead a problem of how do we transfer the taught learnings on one robot to a larger set of robots in the fleet. It goes back to that idea of fleet learning that we mentioned earlier. Now, what the robot is doing now specifically for this task was taught by a human in virtual reality. That means that someone went into virtual reality, a virtual world, wearing the goggles and the hand controllers, and physically demonstrated for the robot the exact wipe task that it wanted it to do. In this teaching process, what the robot is doing is associating things that it sees through its cameras to the exact physical act of wiping that was demonstrated by the teacher. That association, though, is limited to this specific task and perhaps this specific environment and any other object that might be present in the scene. And we recognize that limitation, but moving forward, our research efforts are focused on being able to extend what the robot has been taught to other new environments and being able to adopt new tasks that have been taught in new environments. So it's not just wiping, maybe it can move furniture or fold clothes. And lastly, to be able to transfer everything it's learned in its household to all the other robots that might exist in other households. And what makes a lot of this possible is the ability of the robot to have what we call long-term memory, which is that association that it's able to achieve from what it sees to a previously taught task. And then the other one is short-term memory, the ability of the robot to encode things in its environment in such a way to encapsulate information that it can use to handle collisions, so it doesn't collide with objects in a non-meaningful way, so that it can make sense of the objects that it's holding and also the tools that it's using. Dan is going to talk to you now about a new robot we've developed that is a slightly different configuration than this robot. Let's go talk to Dan.
Thanks, Jeremy. We're not limited to thinking just about software solutions or solutions that have to work in existing human environments. What if in the future we could design homes assuming we'd have robotic solutions like those we might have in Toyota's Woven City? So we're investigating an idea of integrating robotics directly into the home. What if instead of needing a robot to navigate the cluttered floor, it could travel on the ceiling instead and be tucked out of the way when it's not needed? To explore this idea, we've built a prototype robot that flips our current mobile manipulator on its head. This is our gantry robot, and as you can see, it's hanging from the ceiling. Many homes, especially those in Japan, are very small and cluttered and have no room for a floor-dwelling robot. This was a discovery we made in our user experience in-home visits that Steffi talked about earlier. So we decided to explore a robot that could take advantage of space above and be tucked out of the way when it's not needed. The ceiling assistant can do all the same tasks as a floor robot. Like our mobile manipulator robot, this robot is taught to perform tasks by a person in virtual reality. You will notice that our robots have been operating at a speed much slower than usual human action. This is to accommodate operating safely around people and pets. Additionally, the cleaning operation can be done at night when people are asleep, so there's plenty of time to complete the task. Over time, we will continue to improve the operational speed while maintaining safety. For the purposes of this demonstration, we have sped up the playback of the operation. I also want to point out the number of joints or degrees of freedom this robot has. It certainly looks complicated, but it's actually quite the opposite. Having this many joints makes learning easier for the robot, because a lot of these joints are redundant. This means the robot can move its whole body around much more freely with fewer constraints, allowing the teacher to think only about where the robot should be wiping, not how the robot's going to get there. This also gives us some ability to teach behaviors across robots with slightly different configurations, like the one Jeremy showed you. Simulation has also played a key role for developing this robot. When COVID hit and we had to shelter in place, we were forced to get creative again about how to keep our research going. The team designed a simulation of the robot to be able to prototype and test the system first. Only then did we build it here in real life, much faster than we would have been able to otherwise. We are now able to remotely test behaviors in the mock home from the safety of our own home with only a minimal crew in the lab. Even though the mock home is a new addition to our office, it already gives our team the ability to test concepts quickly and efficiently. We plan to finish the mock home construction within the next month and expect the lab to be a vital building block in establishing the future capabilities of robotics at Toyota. Now, to further expand on how simulation is key to addressing the challenges of operating in the home, we're going to send you to our office in Cambridge, Massachusetts, where Russ Tedrake will tell you more.
Thanks, Dan. Hi, everybody. I'm Russ Tedrake. Welcome to our CAM5 Robotics Lab. That's what we call our robotics lab here in Cambridge, Massachusetts. We're just down the street from MIT. And I've got a lot of robots to show you today. What we're looking at over here, we have a robot that's trying to load the dishwasher. So the task is fairly simple. You have plates, mugs, spoons, dirty dishes in the sink. The robot's job is to move the objects from the sink into the dishwasher, and if there's any trash, it needs to discard it to the side. So why would we want to study a robot loading the dishwasher? Well, TRI has a view that we want robots that are useful in the home. And actually, one of the really important things about that is robots that can work alongside people. We're not trying to replace people. We're trying to do tasks, that help people, that work with people. One of the super interesting questions that comes up with that is if I build a system that is capable of doing the complex manipulation required for loading the dishes, it has to use cameras and deep learning, machine learning, artificial intelligence algorithms in order to understand what it sees in its cameras, whether it's a mug, a plate, or a spoon, okay? It has to use complex AI planning software. But somehow we need to, despite all of that complexity, despite the robot having the intelligence to accomplish the task and the dexterity and strength to accomplish meaningful tasks, we somehow need to say, you can trust the robot. It's okay to put the robot in your home. It's going to do the right thing most of the time, and it's safe. So a system that's complicated enough to load the dishwasher has a lot of complicated components. So it has cameras that it's using to locate the objects in the sink. It has machine learning and artificial intelligence algorithms that are interpreting those pictures that it gets from the cameras and trying to understand, is it an object? Where is the object? How should I grab the object? Okay? And a complicated set of planning and control algorithms that make the whole thing work. Now, TRI's goal is to make robots not replace humans, but work alongside humans. To work alongside a robot that's this complicated, that's learning and adapting in a new environment, how do you establish confidence and trust in a robot like that? Now, we've talked to you before at TRI about the problem of autonomous driving and how, in many cases, actually, most of the miles we drive with an autonomous vehicle are easy. But every once in a while, there's a corner case, a rare event. And it's those corner cases that really test the intelligence. The same thing's true in the kitchen sink. To make the same robot work in any kitchen across the world, the real hard part is finding the corner cases, the rare events. The way we try to do that here at TRI is, well, first step, we do a lot of physical testing. We have these robots running as much as we possibly can. But that's not enough. In fact, we can't run enough robots in enough environments here at TRI. So the second part of the story is actually complementing our physical testing with simulation. So TRI has made a big investment in simulation. Now, this is one area where manipulation is a very different problem than autonomous driving. The mechanics of the way the hand of a robot interacts with the objects in the sink, for instance, is actually a very complicated thing to simulate. And traditionally, robotics has not trusted simulation for such complicated problems. We've made a big effort of that here at TRI. In fact, we've made that simulation project mostly open source in a project called Drake. And now we have high fidelity simulation. We run many, many more trials in simulation than we could ever run in the reality. And we use this to build up our confidence, our trust in the robotics algorithms. Now let me tell you about one last experiment. This robot here is actually showing a prototype of how we think robots might be built differently in the future. We've replaced the rigid fingers on a typical robot with soft bubble end effectors that are meant to be a little bit more like the fingertips that you and I have. And again, that changes the mechanics of manipulation, but it also changes the way you can do sensing with manipulation. So hiding behind each of those bubbles is a tiny camera. That camera can see the deformation of the skin every time the robot picks up an object. In fact, this robot is doing a mindless task of just picking up objects all day long and dropping them. The reason it's doing that, though, is that it's learning what the images on the camera look like when it picks up objects. So that's a quick survey of the type of research we do here in the manipulation group in Cambridge. To tell you a little bit more about how we transition our research into practice, let me send you back to California. Thanks for visiting.
Welcome back. As you can see, we're tackling some really huge technical challenges. But those challenges are rooted in real-world needs and the way Toyota can have a positive impact on society. At TRI, while we're pursuing high-risk research, we've learned from and adopted the best practices from Toyota, corporate R&D facilities, government research, universities, and Silicon Valley startups to maximize our impact. To ensure this impact lands in the real world, we work closely with our partner organizations at Toyota and the Woven Group to take the capabilities we develop and turn them into product concepts that could be deployed and evaluated to assist aging populations around the world. In particular, Toyota is creating its Woven City as a human-centered, ever-evolving living laboratory to help facilitate this. And just like a master driver uses a test course to ensure our cars are always better, the Woven City will be a proving ground to see if our capabilities can enable people to live ever better lives and address the difficulties they face. In the end, our goal is to prove what is possible in service of human needs and challenges. We believe happiness comes from fulfillment and feeling truly useful to others. So we focus on fundamentally new robotic capabilities that amplify, not replace, human ability. I'm so proud of our team and to be part of this effort, and I look forward to your questions.